Hi, today I'll be showing you how to solve inequalities. So the key concept to keep in mind is that when solving inequalities, solve them the same as linear equations unless you are multiplying or dividing by a negative number. So let's start off with an example. 5x plus 1 is greater than 2. So let's solve for x. So just as the same as a linear equation, we can bring all the variables on one side and the numbers on the other. So we'll minus 1 from both sides, so that will be 5x is greater than 1, and then we'll divide by 5, so x is greater than 1 over 5, or as a decimal, that's just going to be 0.2. Okay, now there are two main signs in inequalities, so that's going to be the greater than sign and the less than sign, which basically means that, for example, 5 is greater than 3. That's what it means. And in this case, minus 1 is less than 10. So just keep those in mind. And there are two other signs that show up often that you should be very comfortable with. So those are the greater than or equal to sign and the less than or equal to sign, which basically means that, for example, x can be greater than or equal to 0, which means that x can be 0 or it can be anything greater than 0. And in this case, x can be minus 1 is less than or equal to 2x, right? Which basically means that, so 2x is greater than or equal to minus 1, which means that x is going to be greater than or equal to minus 1 over 2. So x can either be minus 1/2, or x is always going to be greater than minus 1/2. Okay, so now let's try another example now that we know that. So in that case, we can try the example minus 3x plus 10 is greater than 40. Okay, so once again, we can bring all the numbers on one side, so we'll subtract 10. So minus 3x is greater than 30. And now, notice something that's very important. We have a minus here, and we're going to be dividing by minus 3 on both sides to get rid of it. But whenever you're dividing or multiplying by a negative number, remember that you must switch the sign, which means that if it's a greater than sign before, it will become a less than, and if it's a less than before, it'll become a greater than. So in this case, it's not going to stay as minus 3x is greater than 30, which will be x is greater than minus 10. That's not what it's going to stay as. So don't make this mistake. What it is going to become is minus 3x is less than 30. We're going to switch the sign, and thus x is going to be less than minus 10. Okay, so remember that. That is very important. Okay, here's a harder example that you might see on the exam. So they might say that, just a second, so that 0 is less than 3x plus 5, which is less than or equal to 20. So this might seem very weird, very bizarre, but what you can actually notice is that this is basically just two inequalities stuck together. So we can actually dismantle this and solve the two inequalities separately. So let's solve the first one, which is 0 is less than 3x plus 5. I like to always bring my variables on the left-hand side just for easier solving, so that's the same thing. So 3x is going to be greater than minus 5, which means that x is greater than minus 5 over 3. And for the second inequality, which is 3x plus 5 is less than or equal to 20, that means that 3x is less than or equal to 15, which means that x is less than or equal to 5. Okay, and oftentimes you're going to be asked to graph the answer on a number line, which means that you need to graph it, and you need to show what x is equal to on an actual number line. So let's see how that will look. I'm just going to draw a simple number line here, nothing special. Okay, so we can set 0 to be here. We'll do 1, 2, 3, 4, 5. And then here we'll do minus 1, minus 2, minus 3, minus 4, minus 5. So I'll just draw those. Okay, and now since we know that x is greater than minus 5 over 3, and minus 5 over 3 is about minus 1.666, so that's going to be around here. So we're going to draw that as an open circle, and I'll explain why in a second. So let's finish graphing. So if x is less than or equal to 5, we're going to draw that as a closed circle. And now we can just draw the line from minus 5 over 3 to 5. Because this is going to be demonstrating all the solutions that x can have, since it's in between those two numbers. Okay, so now let's talk about why I left one circle open and one circle closed. Recall that x was greater than minus 5 over 3, which means that it's not actually equal to minus 5 over 3. It's simply always going to be greater, but it's not actually there. It's going to be anything onwards. But in the same case, x is less than or equal to 5, which means that it can be equal to 5 here. It can be here, and then it can be anything less than 5. So just keep that in mind when you're graphing inequalities.